Imagine you have two AI models. One is a coding genius, the other writes like Shakespeare. What if you could smash them together into one supermodel without any training at all? That's exactly what model merging does. Here's the core intuition. When you fine-tune two models from the same base, they both start at the same point in weight space. Each fine-tune nudges the weights in a different direction. The merged model simply sits somewhere between them. The simplest technique is SLERP, spherical linear interpolation. You take a weighted average of two models. Set alpha to 0.7 and you get 70% of model A blended with 30% of model B. It's literally one line of math. But simple averaging has a problem. Sometimes model A wants a parameter to go up and model B wants it to go down. You average them and get 0, both contributions canceled out. That's where ties comes in. Ties stands for trim, elect sign, merge. First, it trims away small, noisy changes. Then it holds a vote if 2 out of 3 models moved a parameter positive wins. Finally, it merges only the agreeing changes. Clean and conflict-free. Next up is dare, drop, and rescale. It randomly drops 90% of parameter changes and rescales the survivors. Sounds insane, right? But fine-tuning changes are incredibly redundant. That remaining 10% captures almost everything the model learned. Now for the wildest technique. Instead of blending weights, you literally stack layers from different models. Layers 1 through 16 from the coder, 17 through 24 from the writer, and 25 through 32 from the coder again. It's Frankenstein's monster, and it works. The tool that makes all of this dead simple is MergeKit. Install it with pip, write a YAML file specifying your models, weights, and merge method, then run one command. That's it, merged model ready to go. Let's walk through a real example. We have a Llama 3 model fine-tuned on coding and another on creative writing. We use dare ties with the coder weighted at 0.6 and the writer at 0.4, keeping 50% density. One command later, done. You don't even need full models. You can merge LoRa adapters directly. Load the base model, apply the first adapter and merge, then apply the second adapter with a custom weight. Lightweight and efficient. Here's the mind-blowing part. On the Open LLM, merged models regularly outperform both of their component models and the original base model. The combination is genuinely better than the sum of its parts. But merging isn't magic. It fails when models have different base architectures. You can't merge a Llama fine-tune with a Mistral fine-tune. It degrades when you try to merge more than 3 models, and conflicting specializations like one trained to be concise and another to be verbose will fight each other. Here's the practical workflow. Fine-tune Model A and Model B with LoRa. Merge the adapters into the base. Evaluate on both tasks. If quality drops, tweak your weights and density. Then compare merged model versus individual models with a router. Ship whichever wins. To recap, model merging combines capabilities using pure math, no training. Use SLERP for 2 similar models, dare or ties when specializations differ and when you're feeling adventurous. Both models must share the same base, and MergeKit is your best friend. Now go build your own Frankenstein.